Hi guys, physics time, action time. Please go to link, try first. Day 2, electric circuit questions. Question 1, 2 marks question. Let's see what they ask. We have a circuit and then variable resistor we have. They said in this circuit, variable resistance increased now. Okay, if you increase resistance, what's going to happen to your current and voltage? That's our question. Reading on a meter, reading on voltmeter, what's going to happen if you increase your resistance? That's our question. So what's our answer, people? You have your answers already. Please go to link, try first. Don't forget it. So answer is A. Why A? Let's explain. Because if resistance increase, current decrease. Do you know? And then if resistance increase, voltage also increase, because we know our Ohm's law. What was it? V equals I times R. As you see, voltage and resistance directly proportional to each other, but resistance and current, if one increase, other one decrease. Because of that, our answer is A. If resistance increase, current decrease, and then voltage increase. And then you have your 2 marks. Okay, that's our first question. As you know, every day we are trying to answer one multiple choice question and then one long question from different topics. So last lesson, day 1, it was electrostatics, and now electric circuits. Okay, let's continue with next one. Let's see our question 2 today. Let's see what they ask. All right, we have an electric circuit. So what we know, let's check. A battery with internal resistance, all right. Internal resistance we know, 0.5 ohms. And EMF, we don't know, all right. Connect to 3 resistors. Okay, we have 3 resistors, R1, R2, R3, 4 ohms, 25 ohms, 15 ohms, all right. Voltmeter and ammeter also we have. Okay, as you see, voltmeter connect to the battery directly. Okay, this is our circuit. And then question 2.1, another 2 marks. Today's paper, let's say paper, today's paper, 20 marks. Please try to get full mark. So define the term EMF of a battery. As you know, for each question, almost every question, they're asking just 1 or 2 definitions. So please try to memorize all definitions. So last definition, last lesson, what was it? What they asked? Do you remember electrostatics? They ask you one definition. Now asking another one. What is our definition? What they ask you now? Define the term EMF of a battery. Okay, other questions will come from this circuit, but for now, 2.1, define the term EMF of a battery. Answer is coming now. You can write any of these, so you can choose. Please write it down. Please make your list for all definitions. There's no another option, or you can print out, you can find for all topics, get your all definitions list and try to memorize. There's no another option for definitions. As you see, 2 marks. So please try to learn. So EMF definition is here. You can write it down. Work done by the battery to move a unit coulomb of charge across the circuits, or first one, which one is easy for you. You can choose any of these. This is our answer, people. Yes, let's continue. Now, question 2.2. Okay, this is our circuits, already we know. And reading on the voltmeter decreased by 1.5 volts when switch S is closed. Okay, as you see, our circuit switch is open now, but they said if switch S is closed, what's going on? Voltage on voltmeter decreased by 1.5 volts. And they're asking you why. Give a reason why the voltmeter reading decreases. So let's see our answer. This is 2 marks, another 2 marks. Because energy per coulomb of charge is converted to heat in the battery due to internal resistance. So if you use S is open, switch is open, internal resistance you don't need to use because there's no current. But when switch is closed, so you are getting here V lost. V lost, what was the V lost? Do you remember that? V lost is equal to I times R. R means internal resistance. So V lost equals I times internal resistance. I, we don't know, we didn't calculate, it's fine. Just what we know, we have internal, so we are, because of we lost, total voltage decreases 1.5. As you see, they are giving you V lost. V lost is 1.5. But if they ask you, give a reason, you must say because of internal resistance, energy change to heat, convert to heat, just like a light bulb. So for also making resistance change to heat, you know. But this is battery. Battery also has resistance, internal resistance. Till grade 10, you didn't use internal resistance, but when you come to grade 11, so you are using internal resistance also. All right, so this is our answer for 2.2. Okay, time is going, let's continue. So now let's go to next question. 2.2 done. Now let's see what they ask. Okay, calculations coming. I like calculations. Calculate the following when switch S is closed. Okay, they gave you already V lost. It's fine, we can just keep it there. And then calculate the following when switch S is closed. Reading on the ammeter. Okay, they're asking you current. When you get current, so we lost, we have already, and then you can calculate other stuff also. But let's calculate what we know. We can calculate total resistance, right? So we have internal resistance R1, R2, R3, all we know. So you can get total resistance. And then what else we know? Internal resistance we know. So let's see our solution now. How can we get? Yes, using V lost, easy way, because if you calculate total resistance, still you cannot get current because you don't know total voltage, but you know V lost. So what we said, other question, V lost equals I times small r, we said, right? So you are using this formula now. I equals, in memorandum, just giving you Ohm's law formula, it's fine. But for R, you are using internal resistance. For V, you are using V lost. Current is equal to V lost over small r. All right. So when you check memo, they're just giving like this. But please remember, you are using V lost for voltage and then internal resistance for R. So that's our answer. Now we know current. So we know current, as you know, from positive to negative. So we can show direction of current like this. Current is equal to 3A. So now we can calculate our total voltage and then whatever you need, and then voltage for parallel. Just whatever they ask, you can calculate from now. It is easy because you know current. So you know current and you know resistance. All right, 2, 3, 1, 3 marks. I hope it's okay. We lost to get current, total current for circuit. So let's see what else they are asking. Total external resistance of the circuit. Okay, it is easy one because you know R1, R2, R3. What's our step 1? You are calculating parallel combination first, plus R1. So let's see. Yes, for parallel combination, you are calculating, as you see, 1 over R parallel. So formula is here. You know, we have different options for this question. 1 over R parallel is equal to 1 over R1 plus 1 over R2, 1 over 25, 1 over 15. And then, you know, you are going to calculate like this. And R parallel, you are getting 9,375. As you see, you don't round it off because it is not your final answer. This point is very important. Please remember, when you come to final answer, you can round it off. It's fine. But you must round it off, you know, for final answer. But before that, whatever you are having after comma, please try to use everything. All right. So R external is equal to R parallel plus R1, 9,375 plus 4, and then you are getting 13,375, and you round it off, and you are getting 13,38. That's our answer for 4 marks. As you see, first mark coming from formula, and then second mark coming from solution, getting for parallel. To get parallel combination, 2 marks, and then for solution, are external, 1 mark, and final answer with correct units. Please don't forget to write units. Let's see option 2 now. Option 2 is similar, but using different formula. It's fine because that formula and other formula, option 1, similar. You can get this formula from there. And then same solution and done. So another question, EMF of the battery. They're asking you EMF of the battery. Now they're asking you voltage. So you know total resistance, but you must add internal one, don't forget. So you must just add internal one also. So EMF of battery, it's easy now because we have current, we have resistance. From Ohm's law, we know V is equal to I times R. So let's see our solution now. EMF is equal to I times R plus R. You remember, we shouldn't forget internal resistance. If you just calculate I times R, you're getting the external, not internal. It's not total EMF. All right, so I times R plus R. So you are getting, you calculate already external resistance plus internal resistance times by current, 41,64 you are getting, and then your, as you say, you're just rounding off. Please don't forget to round after comma for final answer. We need only 2 digits, people. So 3 marks question, option 1 done. Option 2, another option, as you see, we are calculating the external by using I times R. I just R external resistance times by R current plus V internal. It means V lost. So we lost, V internal, you are adding. It's another option. It's the same thing. So maybe we can show, okay, maybe we can show these two same thing, option 1 and option 2. As you see, V external, what was the V external? V external is equal to I times R external plus V internal is equal to I times small r. And then you can write I times R plus small r. I times R plus small r. All right, as you see, first option and second option, same formula. So we can carry on with next question, 2.4. So 2.4, let's clear all. 2.4, a learner makes the following statement, okay, the current through R3 is larger than R2. Is this correct or not? Choose yes or no and explain the answer. So yes or no, 1 mark, and then 2 marks when you explain your answer. What they said, R3 and R2, they're asking you just R3 has larger current than R2. Okay, so let's see our answer now. Answer is yes. Why? Because for the same voltage potential difference, a larger current will produce a smaller resistance. Because in parallel, we have same. Answer is yes. Why? Because for same voltage, larger currents for smaller resistance because of Ohm's law. You can say they have same voltage because of parallel combination. And then because of Ohm's law, current is equal to V over R. This is our first option. Or you can say V parallel is equal to, as you see, you can just calculate and show. That's another option. But you are going to say yes, and you'll get your 1 mark. And you are going to calculate and show. That's another option, all from memorandum. And then another option you can calculate, V is same. If V is same, as you see, just you are calculating current for each, but it's supposed to I is equal to V over R. So this something is wrong here. It's fine, but you understand in parallel combination, they have same voltage. If they have same voltage, which one has less resistance getting more current? So this is our last question for today. They said the 4 ohms resistor is now removed from the circuit. Yes, they like this kind of questions. So they remove from circuit. How will this affect the EMF of the battery? Choose from increase, decrease, and remain the same. EMF of battery. If you remove 4 ohms from here, it means just open switch. So answer is remains the same because EMF of battery, even as is open, still same. So that's our answer for 1 mark. All right, we have done for today. I hope you get full mark. So see you next lesson, another day. Let's study with you. Please don't forget, you know what you are gonna do. See you next lesson, everyone. Have a nice day.